Hey, what's up?
I'm good. How you doing?
I'm good, thank you.
Thank you very much for giving me opportunity to present you on my show.
Thank you so much. It's an honor for me to be here. Thanks for having me.
So, can you please introduce yourself to my audience and what you want to talk with my audience?
Yeah, sure. So my name is Vlad Khononov. I'm a software architect. I specialize primarily in domain-driven design and distributed systems. And software design is my hobby, which culminated in learning domain-driven design book and the upcoming balancing coupling in a software design book that I hope is going to be published soon.
You are from?
I was born in Belarus, but for the past 29 years, I'm living in Israel.
So, domain related design. So, what made you to do this?
So domain-driven design is a methodology for uh, some people in the industry do not necessarily agree to call it methodology, but for me, it's a set of practices. So I think it's okay to call it methodology. It's a set of practices on approaching development of complex software projects. How do you make sure you understand what the problems you're intended to solve by means of writing software, and a set of patterns and practices for turning that knowledge into code, into solution that you are implementing. That's what domain-driven design means for me in a few words.
And can you tell more about it?
About domain-driven design, well, this methodology was introduced almost 20 years ago, I think, or even a bit more, around 20 years ago, by Eric Evans. He has written a book called Domain-Driven Design, Tackling Complexity in the Heart of Software, and for me it was a career-changing experience getting that book, learning that this topic and applying it in my day-to-day job. So when I started my working as a software engineer, I was always puzzled by this concept of business logic, because at the company I was working at back then, we were spending a lot of time discussing how to implement data access, how to implement UI presentation, all that let's call it sexy stuff that people see, but business logic, it was sort of neglected. Like, it wasn't getting any attention, even half of the attention, like the other areas. And I was looking for guidance how to implement business logic in the best way possible. So I was looking for that guidance for a few years, and Eric Evans's book, Domain-Driven Design, actually provided that guidance for me. So it wasn't an easy book to read, and people are in the DD community are joking that usually you read only the first 4 chapters, and by that point you say, okay, I get the stuff, let's get to work. So yeah, it's not an easy subject to get into. It took me a few attempts to finish reading the Blue Book, especially as an English as a second or third language speaker. It's a very challenging book. So yeah, eventually I did it, and as I said, for me it was a career-changing experience, because applying this methodology to the way you're implementing business logic and software changes everything. It gives you superpowers to implement software that's going to be more adaptable to change and evolution in the future.
So, how domain-driven design uh, can change technology business?
So I'm not sure it can change your business, but if you're looking from a perspective of a software engineer that is writing a software for a company, then domain-driven design provides a set of tools for, first of all, to get a much better level of knowledge about that business domain. It provides you tools for communicating with domain experts, trying to understand how they're thinking about that business domain, and then transform it into a mental model that later on is transformed into code. Now, doing that allows you to design systems that are going to be more modular in their nature. It allows you to write code that is going to take care of business concerns. For example, we can say that business logic boils down to getting input and generating some output. So domain-driven design patterns like aggregates and value objects provide you a set of tools for making sure that that business data is going to be protected by your code, that your code is not going to corrupt that underlying information under any circumstance. Whatever edge case you encounter, if you follow the guidance, the data is going to be protected, so your code will be way more safe to use. And you know, usually when we are writing code, we can be a bit optimistic, saying that, okay, that edge case, it's not really going to happen. It's going to be a really rare occasion. However, you know, if, for example, you're implementing a system that manages financial transactions or a medical system, even a small misstep can have some very big outcomes. And usually these rare things are going to happen on weekends, national holidays, you know, the perfect time for debugging issues. So again, domain-driven design, if we're talking about technical side of domain-driven design, it provides you tools for write bulletproof business logic that will make sure that you are not going to be in that situation.
So what are the main advantages of it?
The main advantages of domain-driven design. So first of all, when we are building a system, our goal is, of course, to write something that works. As I said, it's important to write a system that implements the business logic, that generates the correct output for the input it gets. That's, of course, important. However, that's not the whole picture, because software is called software for a reason. It should be soft. It has to be able to change in the future. And if we're designing a system, then it's probably going to change in the future. If it doesn't change, then probably that project was a failure and nobody's using it anymore. So we have to accept that software has to change. So that's the second main advantage of domain-driven design. It provides you a way to model the business domain in code, to decompose your system into coarse-grained components or even fine-grained components if you want to, in a way that will allow you to evolve and modify the behavior in the system in such a way that the changes are going to be contained in those modules or components. In domain-driven design, we call them bounded contexts, or services or microservices, whatever we call them. But the goal is to make sure to design a system in such a way that change in business requirements should affect only one of those components. And of course, it's not something new that idea that a change should be contained in one component. It's nothing new. It was coined in 1972 by David Parnas. However, domain-driven design provides a set of practical tools for achieving that modularity, for processing the information and the knowledge you have about your business domain and turn it into actual modules that you can work with. I would say that these are the two main advantages. First of all, it helps you to write business logic in a way that makes your code bulletproof, that protects your data. And second, it allows you to design systems in a way that will allow them to be changed in the future, so that you can evolve them and if new business requirements come in, you know, you won't need to change all of it, but only parts that are affected by each change individually.
So which level companies or which level softwares uh, can can benefit with this methodology for a small level or mid level or large?
Yeah, so that's a great question, because initially domain-driven design was introduced for enterprise software, but in my opinion, if you are writing a business system that manages data for a business, even if it's small, medium, or large, it can always benefit from domain-driven design. Now, this methodology is divided into two parts: strategic domain-driven design and tactical domain-driven design. Strategic is all about learning the business domain, making sure that you are understanding the requirements, how the system should behave, and why it should behave in that way. For example, if you're building a medical system, then you have to make sure that the data, the decisions the system makes are correct. And you cannot do it if you do not understand the underlying logic. You have to understand what's going on there. So domain-driven design provides tools such as ubiquitous language. Ubiquitous language, it's a scary term, but the concept is really straightforward. It's almost common sense. The idea is, well, if you need to understand how that system is supposed to work, how that business logic is supposed to make these decisions, all you have to do is communicate with people who have that knowledge. And these are domain experts. Domain experts are people from the business side that either coming up with the requirements for a system, or they're going to be using that software. For example, if we're going back to the example of a medical system, then medical professionals. They know how the system should behave. So we have to get that knowledge from them directly, without any translators in between. Like, if you have watched the movie Office Space, then there is this character that takes the requirements from customers and brings them to developers because he has people skills, and software engineers do not. It's classic movie. Everybody has to watch it, at least first half of it. The second half is not that good, but the first one is awesome. So anyway, that joke in a movie, it's really important, because that's how software projects are traditionally implemented. So we have domain experts coming up with the requirements. They are the source of that knowledge, how the business decisions should be made by the system. However, they are too far away from us, from software engineers. And usually there are a few buffers between us. For example, project managers or business analytics that are communicating with the customer. They're trying to understand what the system has to do. Then they're writing down, they're understanding the requirements, and the requirements are passed to software engineers. And by that moment, when software engineers are reading the requirements and learning what the system should do, there is no interaction. If something is not clear, if something is ambiguous, first of all, we cannot ask the document. Second, we can ask the person who has written them, but we cannot be sure that that person has that knowledge. That knowledge resides in the heads of domain experts. It's there. So the notion of ubiquitous language, of domain-driven design's ubiquitous language, is simple. Software engineers should be able to communicate with domain experts and talk to them about what the system should do. Now, there is a grain of truth in that scene from the movie Office Space, because that guy, eventually in that scene, he gets really angry and he starts shouting, "I have people skills. What's wrong with you people? Software engineers don't have people skills." And that's true. There is some truth to that statement because we tend to, we're technical people. So we want to use technical terms. But domain experts, they don't know these technical terms, right? If we will start talking to them about abstract factories, well, unless you're in a factory business, they have no idea what you're talking about. Or tables. For them, there's no such concept as a table. Again, unless you're working in some financial domain where there are ledgers with tables in them. But anyway, I'm talking here about database tables. They know nothing about that. They also know nothing about other design decisions we are making. So to bridge that communication gap between domain experts and software engineers, again, it's a complicated name, ubiquitous language, but the idea is common sense. We have these two groups of people, domain experts and software engineers. They should talk to each other in a language that everybody understands. So we have, first option is to teach our domain experts what abstract factories and singletons are and database tables and how to index them properly. It's possible. It will probably bore them to death and they will escape, and that communication is not going to be productive, right? So domain-driven design proposes to do it the other way around. Instead, software engineers should be able to communicate with domain experts in their language, in the language of the business. So again, if you're talking about a medical system, if we're implementing a system that is going to be used by doctors or nurses, I don't know who, software engineers should be able to communicate with them in the language of their business, with medical terms. Now, it may sound scary because it sounds as if, okay, are you crazy what you're telling me? That I've been suffering through algorithm and data structure courses in university. Now I have to become a doctor to write a software. Not really. Quite the opposite. We cannot expect software engineers to become domain experts. That's not our goal. Our goal is to solve problems with software. We just have to make sure we understand what problems we have to solve. And to do that, we are usually, what we are doing is we are building a mental model, a view of the world, of that business domain, how it works. But that view of that business domain, it's not comprehensive. Of course, you are not going to become a doctor. However, we do need to gain enough knowledge about that business domain to implement the software. And in domain-driven design terms, it's called building a model of the business domain. Now, a model, by definition, it's not a copy of the real world. It's a structure, it's a construct that is used to help us to make sense of the world, to understand a real world system. It cannot communicate all the details about that real world system, but instead it highlights only a portion of that system that is important for us. In our case, for building a software system. And that's the topic of domain-driven design's bounded contexts. So first, we have to communicate with domain experts in a ubiquitous language. A ubiquitous language is a language that we are formulating when communicating with domain experts that mimics domain experts' way of thinking, how they see the business domain, how they're talking about it, their mental models. In the process, we'll be building our own mental model of that business domain. How can we verify whether it's correct or maybe it's wrong? Well, same way. We can communicate with domain experts, again, using their terminology, and we can verify our understanding with them. That's the ubiquitous language. Next step is we are dividing that understanding of the business domain into models. A model in domain-driven design is usually called a bounded context. A bounded context is a pattern for defining a boundary in which a model can be applied. So why should we do it? Again, to tackle complexity, to manage complexity, because there will be smaller problem domains that can be addressed with one model, and other problems which are going to be addressed more effectively with other models. So we define a bounded context for each one of them. That's strategic domain-driven design. Where first step, we're gaining knowledge about business domain. Second step, we're defining the models, the bounded contexts. Bounded contexts are transformed into a solution domain, in the solution domain to services, or coarse-grained components or modules in a modular monolith, whatever we call them. But the idea is we have to define boundaries for the models. Then domain-driven design provides tools for making socio-technical design decisions. For example, who is going to work on different bounded contexts, how these teams are going to communicate with each other, whether they need formal integration or they can do some ad hoc integration between them. So overall, these are strategic design decisions. And the second part of domain-driven design is tactical patterns. These are patterns that define how you should implement business logic. Now, going back to your original question, whether domain-driven design is applicable to small, medium, or large projects, that part of strategic domain-driven design, in my opinion, it applies to all kinds of projects. Whether you're implementing a small system or a large one or a huge enterprise, you need to make sure you understand what are the problems you are solving with your software. A strategic domain-driven design gives you tools for doing that. The second part, tactical domain-driven design, is all about, as I said, implementing business logic. Now, not only that, you don't, in my opinion, again, it's my experience, my opinions. So I know that there are people who disagree with me. That's okay. I'm judging by my experience. So I've seen projects that follow strategic domain-driven design and do not have even a single tactical pattern implemented in them, and there are still perfect examples of domain-driven design. On the other hand, I've seen quite a few projects that completely ignored strategic domain-driven design and focused on tactical patterns. Tactical patterns have their advantages, for sure, like the mentioned aggregates and value objects. They do bring benefits. However, if you ignore strategic part and focus entirely on tactical patterns, I've seen projects that have nothing to do with domain-driven design, even though there are like tons of aggregates everywhere, and value objects and repositories, etc., but I wouldn't call it proper domain-driven design. It doesn't address the complexity of the business domain. It just introduces cool technical tools that are useful for technical things, but they ignore the business part, which is addressed by the strategic domain-driven design. Yeah, so I feel like this answer to your question was almost half of my book. But yeah, strategic domain-driven design applicable to all kinds of projects, even if you're deciding that, okay, for this project, for this business domain, I don't need domain-driven design. If you evaluated your business domain and its needs, and you're basing your decision on the needs of the business domain, even if the decision is not to use domain-driven design, it's still driven by the business domain, so it's domain-driven design.
You have mentioned very important points, actually. In the global technology business and global technology companies or companies which belongs to different countries and the companies which are developing and working on different projects belongs to different industries. It can be water or electricity or for any for colleges or for projects are based on in different for working technology is working for different companies. So, eventually technology business or technology companies or technology experts are helping human beings to solve their problems using technology solutions that we have. And they are with these solutions that we are providing, we are helping them to reduce their time and energy and effort. So how this methodology, uh, domain driven design in software engineering, how this can change the conventional system that we are already habituated to.
Yeah, yeah, that's an interesting question. And let me think about it. So one way is before domain-driven design came along, software was, and still is, unfortunately, in some places, in a lot of places, okay, it is still implemented as feature factories. Feature factories, you know, when an organization have an R&D team or a number of teams, and they expect to shoehorn them some tasks to implement without really getting to understand what they're doing, they just need to expect the engineers to code, to transform whatever it was they were told into code without applying any thinking, like something that today ChatGPT can do better, probably. Domain-driven design highlighted that, well, if you're seriously investing in that software, then you probably should regard your people as creative human beings who want to solve problems. And to be a problem solver, well, you cannot merely transform things that you've been told. Instead, you need awareness of the business domain, what you're doing, what are the goals, what are the goal of a specific component that you're implementing, and what are the goals of the overarching company. Because, well, let's say that you're working on a small component in a system, in a huge enterprise. However, you're aware of how your company competes with other players in the same industry, with competitors. And there are different companies in the same industry, but they're different companies. They have different competitive strategies. They have different offerings that are focused on different customer bases, for example. So a company has a strategy. If that engineer is aware of how the company competes with other players in the industry, they can identify, hey, maybe here we have an opening for a new opportunity to compete with our competitors in the market. So even if the engineer is working on a fairly bounded functionality, on a much larger scale, domain-driven design, also part of strategic domain-driven design, involves analyzing your business, how it competes with other companies. What are its competitive advantages? And when I'm doing my domain-driven design trainings, at that point, usually somebody is going to ask, hey, I'm a software engineer. I'm not a business person. I'm not an entrepreneur. Why should I really know that? The answer is yes, because of that. Because if you analyze your business domain and you understand how your company works, how it makes money, then your value as an engineer is going to be way higher than merely somebody who translates words into code. And it was true before ChatGPT. It is even more true today. So I would say that domain-driven design allows software engineers to turn from coders, and I don't mean that as a bad word, but here I mean that coder is somebody who only writes code, into problem solvers. And you can be a problem solver at different levels of if we're going to software engineering terms, at different levels of abstraction. You can solve a problem on an object level, on a module level, on a service level, or on company level. Yeah, so I hope that answers your question.
So you're saying that engineer needs to know the business requirement and needs to have what a business strategy is, and because he's working for that business project, which definitely client expects the technology to help to enhance his business.
Yeah.
So you're saying engineer need to be a businessman.
Well, I'm not a businessman, but it always helps, especially during salary negotiations. Just kidding. But that's true. But again, going back to domain-driven design, strategic domain-driven design. Business domain, a company's business domain, we can say that it's the area of its activity overall. For example, say you're Amazon, so you have that retail marketplace, or eBay, again, retail marketplace. Different companies, totally different offerings, even though they have some parallels. A company can have multiple business domains. Again, Amazon, they have AWS, which is cloud computing infrastructure, and they also have hardware manufacturing, like their e-readers, phones. No, they closed that now, but they have movie studios right now, so they can have multiple business domains. These business domains are really coarse-grained areas of activity. Again, Amazon and eBay, same business domain, totally different businesses, right? So for that, domain-driven design proposes a concept of subdomains. So a subdomain is a more fine-grained area of business activity that is required for the company to succeed in its business domain. So we can take a business domain and decompose it into subdomains. So, for example, Amazon, we could say that they have a subdomain for managing their catalog of products, a subdomain for managing their providers, billing, gift cards, etc. In technical terms, a subdomain is a set of coherent use cases. Use cases that are defined around the same set of data and closely related functionalities. Also, usually when a change in the requirements comes in, it usually affects all those use cases in that subdomain. Why am I telling you this? Because subdomains, they are important. However, what's really interesting is that they're not the same. They're not equal. There are three types of subdomains: core, supporting, and generic. And domain-driven design says, hey, you should really make sure to map your subdomains, because it will help you to design software systems better. First, generic subdomains. These are solved problems. These are problem domains that are just in the same way by your company and its competitors. Everybody is solving it in the same way. So there is no business differentiation here. It's probably some open source project or off-the-shelf product that can be purchased. And for example, identity and access. Usually nobody implements it in-house today. Systems for sending emails. Even if you try to implement your own, nowadays it's going to be way harder than just to use an existing solution that's available to you and to your competitors. So these are generic subdomains. These are areas that even if you invest in your own solution, probably it's not going to provide any business value unless you can justify it, unless you purposefully can justify that your solution will provide business value that's not accessible to other players in the market. Now, similarly to generic subdomains, supporting subdomains, they also do not provide any competitive advantage. They're needed. These are areas of functionality that you have to implement yourself. There is no off-the-shelf product or open source solution that exists, but you need that. If you ask your business, they would love to have a generic solution for supporting subdomains, because then you wouldn't have to implement it yourself. And finally, we have core subdomains. A core subdomain is something that does bring competitive advantage to your company. That's something that's unique to your product, something that's not accessible to your competitors, which means we can identify those core subdomains, those areas of functionality that have a direct impact on the company's bottom line. It means that, first of all, that's the area where we should use the most advanced technical solutions to make sure that these areas are implemented in the best way possible. Contrary to supporting subdomains, we can round some corners. They're pretty simple. Supporting subdomains, these are CRUD, data entry interfaces, ETL jobs, stuff like that. Really simple functionalities. So here we can round some corners. If we need it, we can save time here we can outsource them, we can use some rapid application development frameworks, etc. Unlike core subdomains. Core subdomains, well, that's where we don't want to make a mistake, because even a small mistake can have some big effect on the company's competitive strategy. So going back to your question, should software engineer be good at business? Well, it never hurts, first of all. Second, at the very least, a software engineer should be able to fathom the business domain they're working in and to dissect it into subdomains so that they can find those core subdomains and identify them. Because that will allow them to focus on the important stuff. Whereas generic subdomains, well, we can use an existing solution. We don't have to implement it ourselves. Supporting subdomains, we have to implement it ourselves, but these are much simpler things, so we can round corners, we can be pragmatic. That's the area where this word pragmatic applies, supporting subdomains. You don't want to be pragmatic in a core subdomain. Core subdomain, once you identified that's your company's competitive advantage lies in that functionality, well, it gives you superpowers as a software engineer, because now you know these are areas that should be implemented the best way possible. And if you find some creative ways to solve the business problem, or maybe a new problem for the customer that you can solve, that you can address with your software, that's a new competitive advantage for the company. Again, it gives you engineering superpowers. You're solving problems at multiple levels, both at software level, whatever component you're implementing, but you can also help your company to be more competitive in the market. I hope that answers your question, and I think that was like another third or half of my book.
And it seems like it works for large scale companies more than mid-level or small-level companies.
Well, I have to disagree here, and I have an example. In my book, in the final chapter, I share a case study of how I was implementing domain-driven design in a startup company. And that startup company started really small. Initially, we were 2.5 people, half it's me, and we were working out of, in the US they call it in a garage. Here in Israel we're calling it a living room. So we were working out of a living room from one of the founders, and it was really a small system. Even though we have like big plans for the future, come on, at the moment 2.5 people, we know what we are doing. It's not going to be the next Amazon, right? So its functionality was really limited. However, because we invested in those strategic aspects I told you about previously, like formulating a ubiquitous language, decomposing it, building models, decomposing the solution into bounded contexts so they protect those models in services. That allowed us to extend that system, to grow it in a huge system in the future, to add more and more functionalities to it. Now, if conversely, we wouldn't invest in it and we would just do like, just write something that works and let's let tomorrow take care of tomorrow. That's what people say when they're doing that. Well, I bet, like seriously, would put my money that won't be able to extend that system in such a quick way as we did without applying strategic domain-driven design initially. So in my opinion, even if you're working on a small project, come on, it's probably not. So we have to ask, what are the ambitions? If it's a small tool that's not intended to grow in functionality, then maybe you don't really need it. However, if we're talking about a business system, even if it's a small business system, if it's successful, and I bet people want it to be successful, it will grow in the future. Growth is an inherent part of any system. Whatever system you are looking at, systems tend to grow. Software systems grow by adding new functionalities to them. So even if it's a small one or a medium one, if you care about growth opportunities in the future, you still need strategic domain-driven design early on. That's, again, my opinion, which is based on my experience.
And tell me about your books.
Yeah, so that company, by the way, I told you about, that small startup, so we ended up being a group of 3 companies. So it was growing like crazy. And I had to introduce people to domain-driven design. And initially I was trying to force them to read books, but never worked. And eventually I started, taking people to crash courses. Come on, let's go to a conference room. Let's talk about domain-driven design. Over the years, I formulated my way of explaining this methodology that proved to be the most effective, that allowed people to get the grasp of the core ideas and to apply them in practice. So this way of explaining domain-driven design turned into my book, Learning Domain-Driven Design. It's not as comprehensive as its competitors, like Eric Evans's original DDD book or Von Vernon's Implementing Domain-Driven Design book. It's not intended to be a comprehensive guide. I call it a brown belt book. So you're a white belt in domain-driven design, you read my book, Learning Domain-Driven Design, you get the brown belt. You get the minimum knowledge about the methodology that is needed to start using it, to understand it, and to start applying it in practice. If you want to be a black belt, you have to pick up Von Vernon's Implementing Domain-Driven Design and Eric Evans's Domain-Driven Design, Technical Complexity in the Heart of Software. So my book will take you from white belt to brown belt. If you want to be a DDD black belt, you still have to read Von Vernon and Eric Evans's books. So that's my Learning Domain-Driven Design book. It was published 2 years ago, and for 3 years I'm working on another book that's called Balancing Coupling in Software Design. It's a bit different. It's also about software design. However, it's more about my own research into this topic. And as I told you in the beginning, when I started my career as a software engineer, I was puzzled by this business logic. And I was looking for guidance how to implement it. I found it in domain-driven design. Another subject that I was puzzled is coupling. So whenever you look, you will hear coupling is bad, cohesion is good. Maybe you will also find some abstract definition of these concepts, but nothing that can be applied in day-to-day. So for about 7 years, I was researching the notion of coupling. What is coupling exactly, how it manifests itself in software, and most importantly, how should we address it when designing systems? And that research led me to a model that I called balanced coupling. I used it in some day-to-day projects. The results were really good. I really liked the way it allowed me to design software and also to introduce these concepts again to people, to teach them how to design coupling effectively. So that research, that model, balanced coupling, led me to do a stupid thing, to write another book, and that's Balancing Coupling in Software Design. It's supposed to be published by the end of this year, 2023. I hope it's going to happen, but I cannot promise anything because I've been promising it for 3 years already. But from my side, all I can tell is that the final draft manuscript is ready. It's out there. It's in the process to be in production any day now. So yeah, that's my second book, Balancing Coupling in Software Design. I pour my soul into it. I hope people are going to like it.
And what do you say to the software engineers and business leaders who are listening to you and watching you now?
Talk to each other. Talk to each other. If you're a software engineer and you're working for a company, well, your manager will give you tasks, things that you have to do, but to be effective on micro scale, you have to be also aware of the macro scale of the role, what you're doing plays in the company. And that will allow you to be a problem solver, not only on software level, but also on business level. And hint, that's a good way to get promoted. And business people, talk to your software engineers. Make sure they understand the business they're working in. Test them. Usually we're tested for implementing quick search algorithms, which are useless. Well, they're very useful, but we are not doing it in our day-to-day work. Nobody cares about that. But if somebody is working for a company for a year or 2 years, well, make sure that understand the business of the company, the business domain, how it competes with other companies. Make sure the values of the business and of your engineers are aligned. If they are, that gives you, again, superpowers. Your software engineers are going to be problem solvers. And problem solvers at multiple levels of abstraction. Again, I told you that software engineers use technical terms, and here I am using layers of abstraction again.
So, also to domain experts.
Domain experts. Well, domain experts talk to your software engineers because I've heard different experiences. In my experience, domain experts were really cooperative and really wanted to communicate with software engineers. And in many cases, it was caused by their prior experience of software engineers that didn't want to talk to them and were implementing stuff that had nothing to do with the business. So in my experience, they really wanted to cooperate. However, I encountered cases of domain experts not really willing to do it. And well, if you really want to get a solution to your problems, you have to communicate with people in charge of that, building that solution to your problems. Make sure that you're on the same page regarding the problem they're solving and how do you expect them to solve it. Like, what are the algorithms they have to implement, their business rules, and and overall business decisions that the system has to make. And to all three groups, if you need to find that common language between all of you, then there is a workshop called Event Storming. That's a great way to take these three groups of people and force them to speak to each other and to do it in the language of the business domain. Event storming. That's a practice that came out of domain-driven design community. Alberto Brandolini coined it. It's a fantastic way to share knowledge in an organization.
And what is your observation about my work?
Sorry, what?
What is your observation about my work?
Your work. I looked at your YouTube channel and I saw some cool guests there, like Jeff Barr from Amazon. I didn't really understand what was going on with his hair there on that video, but it's cool. So yeah, good job on building a big community of people sharing their ideas. That's how we grow, by sharing ideas. That's how universities, academy worked in the past. In the past it was effective. Right now I'm not sure it's effective because reasons. But right now we have our software industry, and that's how we are growing, both individually and collectively as an industry, by sharing ideas and having podcasts and other mediums for sharing ideas is a great way of doing it.
So I personally did masters in software engineering, also bachelors in computer science and engineering. Right now I'm working for a UK company as a cloud DevOps engineer and software developer. So me talking with experts like you, who are into different countries and who are into different companies and who are working in different fields and different projects, and me trying to know what they are doing and how they are solving problems in different places and different parts of the world and working in different projects. Not only technology projects and technology experts and technology founders, CEOs, CTOs, like you saw, Vice President of Amazon Web Services. Also, I interviewed the Vice President of Salesforce. Engineers, developers, also the business leaders, and also people who are completely out of technology, like authors. Recently, I interviewed a police officer from Toronto, Canada, who served for police department for 30 years. So I interviewed authors who wrote different books, like psychological books and fantasy books. And also I interviewed some doctors, psychologists. So me trying to do this kind of a work, which is completely different from my full-time job is. So how this communication, global communication skills and global network and international relations are going to help in coming days in my technology work.
Yeah, that's really cool, and especially what you said, that you're not focusing only on software engineers but also on different fields. That really resonates with me because, again, going back to that coupling project, coupling research book, in my opinion, one of the most important chapters in that book, it is based on research that was done in other fields, in social sciences and biology, physics, etc. These are topics that were not really covered by other sources in our industry, but I was able to find these concepts in those other fields. So yeah, bridging ideas and using the tools we have nowadays to bridge the geographical gaps between us. It's amazing. Yeah, and I always recommend. There is a book that I always recommend to read. No matter who I'm talking to. It's called Scale by Jeffrey West. And in this book, that's by the way, the book that is that the chapter I told you about, it's based on. the work of Jeffrey West. So in that book, he provides a model of how systems grow. Again, we talked about it, how different systems grow and why they're growing. What is the benefit of growth? And as he was researching these topics, he uncovered lots of interesting things, like what are growth limits for different systems, and how these growth limits can be extended. And he claims that innovation is a way to extend growth limits in different systems, and he demonstrates it with different in different areas, social sciences, biology, physics, etc. Always there is some innovation that allows extra growth. So going back to your question of how this sharing of ideas between different industries, different fields, different countries, well, that's innovation that Jeffrey West talks about. That's innovation that allows ideas to flow more effectively, to more effectively generate new ideas. And as a result, there is this system that we are part of called humanity, and it has its growth limits as well. And innovation allows us to extend our growth limits, the collapse of our system. It probably will come at one day, sooner or later, but innovation allows us to extend it for some time now.
So can you share your web links with my audience?
Yeah, of course.
Can you spell your social presence to my audience, to my podcast listeners?
Yeah, so it's VLADIKK. So Vladik, but double K at the end. You can find me on Twitter with that handle, and on GitHub, which is kind of boring right now, and on LinkedIn it's my Vlad Khononov, but I do not expect anyone to catch my name or to spell it correctly, so I'm not even trying. Look me up on Twitter, Vladik, VLADIKK, and also my blog, which someday I will get back to. It's also VLADIKK.com.
I'll put your web links in the description, also in the on the screen as well. People who finds our video on YouTube and on internet can able to see it and can see what you're doing and can learn from what you are presenting and what you're sharing.
Awesome. Thanks so much.
And also I'll put your biography and with your web links on my website as well. People who visits my site can able to see your work in my site. Through my site, they can reach you.
Awesome. Thank you.
Can I put this video on my YouTube channel with your permission?
Yeah, of course.
And also, can I put this audio and video clip on my podcast website, internet, social media, everywhere with your permission?
Yeah, of course.
Thank you again, Vlad, for your valuable time and sharing about domain-driven design and also about software engineering and how it is interconnected and how it is helping how it can solve problems to humanity.
Yeah, my pleasure. Thank you so much for having me. And yeah, and sorry for postponing our meeting a week ago. Or a month ago. I don't remember what it was.
Thank you again.
Thank you.
Bye.
Bye-bye.